Chapter 3. Rotation and Revolution of the Earth. Nicholas Copernicus, a Polish astronomer, in the 16th century, was the first to say that the Earth only appeared to be stationary. Actually, the Earth not only spins on its axis, but it also moves around the Sun. The movement of the Earth on its axis is called rotation, and the movement around the Sun is called revolution. Rotation of Earth. The Earth rotates on its axis from west to east. The axis of the Earth is an imaginary line which passes through its center. This is due to the rotation of the Earth. In the same way, it is the Earth that is moving and not the Sun. The Earth takes about 24 hours or 1 day to complete one rotation on its axis. Thus, rotation is called the daily motion of the Earth. The Earth covers this distance in about 24 hours. Effects of the Earth's rotation. It makes us feel that the Sun, the Moon, and other heavenly bodies move from east to west. It causes the bulge of the Earth at the equator and flattening at the poles. It is responsible for days and nights on Earth. It gives us identify the direction based on sunrise and sunset. It is responsible for the tides. The circle of illumination. The Sun is the main source of heat and light for the Earth. Due to the spherical shape of the Earth, only one half of it gets light from the Sun at a time, and the other half remains in darkness. The circle of illumination is an imaginary line which separates the lighted part of the Earth from the dark one. Revolution of the Earth. The Earth, while rotating on its axis, also revolves around the Sun. The Earth takes 365 days, 5 hours, 48 minutes and 56 seconds to complete one revolution around the Sun. The time taken by the Earth to go round the Sun once is called a year. Thus we refer to revolution as the annual motion of the Earth. After every consecutive 4 years, 5 hours, 48 minutes and 56 seconds are added to form one full day. On 4th January every year the Sun is closest to the Earth, and this is known as perihelion. When the distance of the Earth and Sun are maximum, the Earth is said to be in aphelion. Effects of the Earth's revolution. Some of the important effects of revolution of the Earth around the Sun causes variation in length of day and night, in the distribution of heat over the surface of the Earth, and the phenomenon of seasons. Effects of the Earth's revolution. Some of the important effects of revolution of the Earth around the Sun causes variation in length of day and night, in the distribution of heat over the surface of the Earth, and the phenomenon of seasons. The change of season is due to the revolution of the Earth and the inclination of the Earth's axis. We already know that the orbit of the Earth is not a perfect circle, it is elliptical. So when the Earth moves around the Sun, it is nearer the Sun at certain times of the year. The portion of the Earth which is tilted towards Sun has summer season, while the portion of the Earth which is tilted away from the Sun has winter season. Difference between rotation and revolution. Rotation. Revolution. The spinning of the Earth on its own axis is called rotation. The movement of the Earth around the Sun is called revolution. The Earth takes 24 hours to complete one rotation. The Earth takes 365 and a quarter days to complete one revolution. The effect of rotation is day and night. The effect of revolution is the change in seasons. Solstices and equinoxes. As the Earth orbits around the Sun in an elliptical path, the Earth's surface receives sunlight at various angles. An equinox refers to a day having equal duration of days and nights. On the other hand, solstice refers to a day when the Sun is standing still on a particular latitude. Winter solstice on 22nd December and summer solstice on 1st June. Summer solstice, 21st June. Conditions prevailing in the northern and southern hemispheres. During the summer solstice, the northern hemisphere is inclined towards the Sun and the southern hemisphere stays away from the Sun. Sun rays fall vertically on the Tropic of Cancer while they fall slanting on the Tropic of Capricorn. The northern hemisphere receives more light and heat from the sun as compared to the southern hemisphere. So, it is summer in the northern hemisphere and winter in the southern hemisphere. The areas near the poles receive less heat as the rays of the sun are slanting. In the northern hemisphere, days are longer than nights while it is the opposite in the southern hemispheres. 21st June is the longest day and the shortest night in the northern hemisphere, while it is the shortest day and the longest night in the southern hemisphere. In summer solstice, the North Pole is inclined towards the sun and the places beyond the Arctic Circle receives continuous sunlight for about 6 months. Winter solstice, 22nd December. Conditions prevailing in the northern and southern hemispheres. At this time the southern hemisphere is inclined towards the sun, while the northern hemisphere stays away from the sun. Sun rays fall vertically on the Tropic of Capricorn and slanting on the Tropic of Cancer. Since the sun's rays fall vertically at the Tropic of Capricorn, a larger portion of the southern hemisphere gets light. So, it is summer in the southern hemisphere with longer days and shorter nights and winter in the northern hemisphere. 22nd December is the longest day in the southern hemisphere while it is the shortest day in the northern hemisphere. During winter solstice, North Pole remains in the darkness for about 6 months, while the South Pole receives sunlight for about 6 months as the southern hemisphere is inclined towards the sun. Australia, Argentina, Chile, etc. are the countries that celebrate Christmas in the summer season. Equinoxes. The word equinox means equal nights. The sun's rays fall directly over the equator, so we have equal days and equal nights. 21st March and 23rd September are called spring equinox and autumn equinox. The spring and autumnal equinoxes, 21st March and 23rd September. On 21st March and 23rd September the sun rays fall vertically on the equator. At this position, neither of the poles are tilted towards the sun. So, the whole earth experiences equal days and equal nights. During the spring and autumnal equinoxes, the temperature remains mild. On 21st March, the northern hemisphere experiences spring and southern hemisphere experience autumn. The condition is reverse on 23rd September, when it is autumn season in the northern hemisphere and spring season in the southern hemisphere.